Hi, this is Yuri from Tracelabs. Now I'm going to give you a quick demo of our network operating system. But before we hop into the demo, I'd like to spend a few moments talking about OriginTrail, which is the underlying technology that the network operating system interacts with. OriginTrail Decentralized Knowledge Graph, or DKG for short, lets you create enterprise-grade trusted AI solutions by turning data from any source into trusted knowledge that you can then use to create AI solutions such as AI-powered search, chatbot-like applications to chat with your knowledge, and many others. OriginTrail ensures that your data stays in your ownership. It can be made discoverable over a public index, and it has integrity verifiable via blockchain. It also allows you to use your trusted knowledge to fuel AI solutions with minimized hallucinations and maximized data management control. And this is really where the network operating system, or nOS, comes in. It helps you speed track your implementation on OriginTrail DKG, and by connecting any data source to the OriginTrail DKG and creating knowledge assets, which are really verifiable containers of knowledge that you own. It also comes equipped with a generic AI application support, such as semantic search over your knowledge assets, which we'll look into through this demo in a little bit. Now that we have covered the basics, let's have a look at how everything works. So what you see here is the network operating system login screen. So I'm just going to log in with my demo account, and we have landed on our data section. This is a section where we can see all of the data sets that have been ingested into the nOS to be turned into knowledge assets. Now, data ingestion works with nOS, of course, manually and or via API ingestion from any IT system, really. For the purpose of this demo, we're going to import a dataset manually and turn it into a knowledge asset. So I'm going to go ahead and select the dataset. Now, what we're importing is actually a medicine leaflet of a fictional medicine that we can use just to demonstrate how everything works. As we can see, the data is processing, and as the data will process, we can go into the stage file section, and we can see that the you make roll leaflet, so the fake medicine or the made-up medicine leaflet actually has been prepared to be turned into a knowledge asset. We can see how the data set structure looks like here, and we can actually go ahead and create this asset. Now that the asset has been created, you will see that it has assigned a UAL, which is a unique asset locator. It's a unique identifier for locating assets on the decentralized knowledge graph, akin to the URLs in the Web 2 world. Now, in the knowledge asset vault, we can actually see all of the assets, knowledge assets that we have created from our data. In this case, we can see on top here that this is the knowledge asset of the leaflet document that we have created before. And we can see actually here that how this looks like, how this leaflet looks like in graph form represented as a knowledge asset. So if we zoom in a little bit more, we can see that this is a knowledge asset with a certain UAL, so unique asset locator. It contains information about a specific resource, which is the leaflet, and we can actually see the content of that leaflet. We can also go here on the left side in the knowledge asset profile card and actually explore the content in a more, let's say, human readable form, so that you can see all of the sections essentially are contained within the knowledge asset. And the exciting thing and the very important thing here is that this knowledge asset, each knowledge asset has also a status update section where you can actually see when the knowledge asset was created. You can see when it was updated, when it was transferred, if the ownership was transferred. And all of this is verifiable on the underlying blockchain, which we can also actually see the ownership of the knowledge asset. We can see it as in the form of an NFT. So if I click on here, it will take me to the NFT that represents the ownership, the underlying ownership of this knowledge asset and the knowledge that is contained within. But going back here, the kind of the last thing to just quickly show is the connectivity of these knowledge assets. So this is a knowledge asset of the leaflet. One of the things that was also contained in the data set that we turned into a knowledge asset is actually a connection to another knowledge asset, which we can actually see in here. And we can see that this knowledge asset, this is describing the leaflet. This leaflet belongs to another resource, and we're going to click on this now to open it. And if I zoom in here a little bit, we can actually see that this belongs to property essentially opens up a product. So we know that this leaflet belongs to a certain product, which is called UMakeRoll 500 mg tablets, and all of the metadata or descriptions around the product that are available are visible here. So this just gives you a bit of an insight into how the knowledge assets are created, how you can view them in your knowledge asset vault, and how they can connect to one another. And of course, the different knowledge assets can be connected even if they're not from the same owner. So this comes really into play with complex business networks. Now you have, if I return back to the knowledge asset vault, we have all of these knowledge assets. We can explore them, we can view them in the Explorer type of view that we just looked at. But the exciting part is now that we have created this knowledge asset, nOS actually allows you to run AI-powered search on it, or semantic search on it. So I'm just going to quickly open this interface here, and essentially the knowledge asset that we created, we can now chat with essentially. So think about the medicine leaflets and what you would usually ask. So let's say we have scanned the product, or we created this knowledge asset. We then scan the product, and we want to actually chat with this knowledge asset and want to ask, for example, what are the side effects of UMakeRoll? Now what happens here is that we, through this interface and certain AI techniques such as vectorization, are running a semantic AI-powered search on this knowledge asset, which will find all of the pieces in the knowledge asset, or multiple knowledge assets if we have many of them connected, and present the answer here. So what are the side effects of UMakeRoll? This is presented to us in exactly the same form and shape as in the knowledge asset. So what does this mean? This means that in this form, there is 0% chance to get a hallucination. And hallucination meaning to get a response that is not true, because it is just generated by the AI. So what we can do with this now, so we have the response. We see all of the things that are that are highly likely to answer a question. In this case, we see all of the possible side effects. We see also the source knowledge asset where the answers came from, which is very important, because you can always actually click on it and it will take you to the knowledge asset where this came from. This is the same one as we just looked at before, and you can see all of the parameters here. And you can also, of course, see who the owner is, who issued it, when, and all these things. But coming back to the semantic search, what we can then also do, so we have done this extractive search, which essentially uses vectorization to give us exact extract from knowledge assets. But we can combine this, if we move this to extract and summarize, we can combine this with large language models and generative AI. So if we wanted to have, let's say, a more summarized answer, what we can do is we can ask the same question. So what are the side effects of UMakeRoll? By switching the mode to extract and summarize. And let me write this down again. And what happens now, this same extract that we looked at above is going to be sent to an LLM. In our case, we're using OpenAI, to actually summarize or make it a more concise, human-readable paragraph than the extract alone. And by doing this, we open up essentially knowledge assets to and this trusted knowledge foundation to generative AI capabilities, but at the same time minimize the chance of hallucinations, because we're feeding the large language model a very concise and the response that actually contains the answer, or highly likely contains the answer to the question. So we're feeding it this thing. So that is kind of a simple way of how you can create, so turn your data into knowledge assets, explore them, and then actually also using the built-in functionalities of nOS actually run semantic search on them. And this is just one example, of course, and one large language model that we have shown here in the demo. But you can really do a lot of exciting things with this, and of course swap out the models, do different types of searches. All of this possible, of course, based on the underlying knowledge assets as the kind of the trusted foundation powered by the OriginTrail decentralized knowledge graph and made easy to use by the Trace Labs network operating system.